Today's video, we are going to be studying carboxylic acids, and here we have the outline of what we'll be discussing. What are carboxylic acids, acidity, synthesis, and uses of carboxylic acids. Now, carboxylic acids are a group of organic compounds that contain the carbonyl group, just like aldehydes and ketones. Now, for carboxylic acids, the carbonyl group is attached to an oxygen atom by a single bond, and the oxygen atom is also bonded to a hydrogen atom. Okay, now this forms the functional group of the carboxylic acid, COOH. Okay, now of course, being the functional group, it determines the chemical properties and the chemical reactions that carboxylic acids undergo. Now let's take a look at the acidity of carboxylic acids. Now, carboxylic acids are organic acids, and typical of most or all organic acids, they are weak acids. Okay, what this simply means is that carboxylic acids dissociate partially, and to be precise, they dissociate partially in water. Okay, now take for example, we have methanoic acid, which is HCOOH, and it can be represented like this, okay, with the carbonyl group and an oxygen atom and hydrogen on the other side. Now, the hydrogen here highlighted in blue is the hydrogen atom that is responsible for the acidity of the carboxylic acid. Okay, it has a positive charge, so to say, and of course, due to the fact that oxygen is highly electronegative as compared to hydrogen, it makes sense that this particular hydrogen is the hydrogen that is responsible for the acidity of carboxylic acids. Now, using methanoic acid as an example, would have the dissociation process go on in this manner. Okay, so it would exist as an equilibrium reaction, okay, with the methanoid ion having the negative charge and the hydrogen ion here. Okay, this is the hydrogen ion responsible for the acidity, and carboxylic acids are weak acids because of this equilibrium. Generally, dissociation reaction for strong acids is a one-way reaction, a forward reaction. Okay, now specifically for carboxylic acids, the dissociation is just about 1%. Okay, now let's move on to the synthesis of carboxylic acids. Carboxylic acids are synthesized by the oxidation of alcohols or aldehydes. Okay, now the process starts like this. So take for example, we have methane, which is an alkene, with the formula CH4. Methane is oxidized into an alcohol, methanol, which is CH3OH. Now, methanol is oxidized into methanol, which is an aldehyde, with the formula CH2O. Now, methanol is oxidized into the carboxylic acid, methanoic acid, with the formula CHCOOH. Alright, and further oxidation will lead to the production of carbon dioxide. Now let's take a look at this. We earlier mentioned that oxidation in organic chemistry is simply the replacement of a carbon-hydrogen bond with a carbon-oxygen bond. Now we have methane as our starting point. Okay, so this is methane with 4 carbon hydrogen bonds. Now we want to replace this carbon hydrogen bond with a carbon oxygen bond. So this bond would be broken in order to form a carbon oxygen bond. Okay, so we'd have C, of course, our 3 hydrogen would remain in place, and now we have an oxygen bond. In place of carbon hydrogen, we now have carbon oxygen. Okay, and then we would have a hydrogen here. This is an alcohol and it has the name methanol. Now on further oxidation, we would have this carbon hydrogen bond replaced by a carbon oxygen bond. Okay, now in order for this bond to be replaced by a carbon oxygen bond, the bond between oxygen and hydrogen also has to be broken. Okay, so oxygen has to break its bond with hydrogen in order to form a double bond with carbon. Okay, so 2 bonds are broken, and now we have an aldehyde, methanol, okay, with the suffix al. Now we'd have something that looks like this. Of course, we'd have the carbonyl group, which is the double bond now formed, and we still have 2 hydrogen atoms here. So hydrogen here and then hydrogen here. Now further oxidation would lead to the replacement of carbon hydrogen with carbon oxygen. Okay, so this would lead to something like this. A double bond between oxygen and carbon remains, and now we have another carbon oxygen bond. Okay, so we have another carbon oxygen bond, and we have a hydrogen here and another hydrogen here. Okay, still intact. Now further oxidation would lead to the replacement of this last bond, the last carbon hydrogen bond, with a carbon oxygen bond. Now however, for us to replace it with a carbon oxygen bond, the bond between oxygen and hydrogen here must be broken. Okay, so we can form a double bond between carbon and oxygen, this oxygen. Okay, so we'd have C, then double bond from here, and double bond, the new double bond that we have here. This is the oxidation process all the way from methane and down to carbon dioxide. So we can see that if we have an alcohol, we could oxidize the alcohol directly to be a carboxylic acid, and we could oxidize aldehyde to be a carboxylic acid. Now this is how carboxylic acids are synthesized. Now it's also important for us to take note of the fact that yeast actually has the ability to ferment sugar and produce alcohol. Okay, now this alcohol, as we have seen on further oxidation, becomes carboxylic acid, and carboxylic acid is actually responsible for the sour taste that we have in some juices. Okay, so it's important for us to take note of that. Now let's take a look at the uses of carboxylic acids. For the uses of carboxylic acids, would be considering methanoic acid and ethanoic acid. Now ethanoic acid has the formula CH3COOH, okay, and it can be represented like this with the hydrogen atoms attached, and then of course we have the carbonyl group, oxygen and hydrogen. Now Rather, ethanoic acid is an important solvent in organic chemistry. Okay, and this is a good example of the production of carboxylic acid from fermentation of sugar. Okay, so yeast ferments the sugar and it's converted into ethanol, and ethanol is further oxidized into ethanoic acid. Now for our second example, which is methanoic acid. Methanoic acid has the formula HCOOH. Now methanoic acid also has the name formicus, okay, and it's partially responsible for the pain and the irritation that we get when we have an ant bite. Okay, so the ant basically injects this formic acid and it causes the pain and the irritation. So these are just the two examples that I would be considering for this video. If you liked this video, please give it a thumbs up and don't forget to subscribe. Thank you for watching. Bye.